Okay, so today is radical expressions. Our objective today is to simplify products and quotients of radicals. So here, when we're going to multiply and divide, what you're going to be doing is when you multiply, you'll multiply the whole number times the whole number and the radical times the radical. Now, sometimes when your radicals are really large, it might be easier to break them down first and look for pairs instead of multiplying really large numbers. Now, over to the right there in example 1, I've written a second example. But let me go ahead and do the first one. And this is the one that's in your textbook. And I'm going to go ahead and do it like they've done in the textbook. And I'm going to multiply the two whole numbers together. So the 3 times the 4, or the two numbers that are outside of the radical together. And then you can multiply inside the radical or under the radical together. So then I would get 2 times 18, and I would get 36. And now I would need to simplify that radical. Now 36 is actually a perfect square. So I would square root the 36, and out of that comes a 6. Bring down the 12. Now notice these are side by side, so this means to multiply. And then I'll multiply 12 times 6, and I get 72. Now, just to show you with a smaller number before I get to those really large ones, another way to do this is, let's say when I multiplied 2 times 18, it wasn't a perfect square. Another method that I could use to solve this, and let me rewrite the problem, is I could break down the radical first. So what I could do is, the first one I can't break down. So let me just rewrite the 3. I'm going to rewrite the 2. But on this one, I could actually break down the 18, and I could make it 2 times 9. So if it were really large, then this might be a method that you might want to do. So then I could take my 2 outside numbers, put them together, multiply that. Then I could make the pair 2's. This becomes a 2. And then the square root of 9, or you could even break it down to 3 times 3, which is a pair, and 1 comes out. So then 2 times 3 is 6, and then you get the 72. So I'm going to show you that on the one that I hand wrote over to the side, because the numbers are really large. So for example, if I did this, I'd have to do the 2 outside numbers, 5 times 3, and get 15. And then next, what I would be expected to do is multiply the square root of 35 times the square root of 28. Once I multiply that, I'm going to get a really large number, and then I'm still going to have to break it down to see if there's a perfect square in there. So instead, what I'm going to do, instead of multiplying and getting 35 times 28 and getting that big number, I'm going to factor this. And then it makes my problem a little bit easier. Now, I've already taken care of the 3 and the 5. I've got a 15 that's outside of the radical. So for the 35, I'm going to break this into 5 times 7. And for the 28, I'm going to break that into 4 times 7. Now, at this point, if you realize 4 is a perfect square and you have a pair of 7s, all of that is going to come outside of the radical. But let me go ahead and keep breaking this down till it's prime, because I know some people like to keep working till it's prime and then look for the pairs. So now notice I have a pair of 7s and I have a pair of 2s. So one of the 2s will come out, one of the 7s comes out, and then the 5 stays underneath because it didn't pair out. Now I still have this 15 that was outside. So now I'm going to multiply everything that is outside of the radical, and I can multiply in any order. I'll multiply 15 times 2 is 30, and then 30 times 7, and I get 210. So 210 square root 5 would be your final answer. Now, if you prefer to multiply the 35 times 28, you're still going to have to go back and break that down. So sometimes it's easier to break it down when the numbers are smaller. Let's try the fraction example. Now, these were examples of multiplying radicals. I'm now going to do the fractions. So again, remember, when you have a fraction, that means to divide it. However, what I'm going to do on this one is I'm going to actually put everything together under the radical. So notice that it's asking me to multiply these two fractions. So I'm going to take everything and put it together under one radical sign. Now, before I start to try to multiply 3 times 14 and 7 times 28, I can simplify here on the diagonals. So I could simplify the 3 and the 27, and then the 7 and the 14. So just like you did when you learned how to multiply fractions. So now what remains under my square root symbol is the square root of 2 over 9, because 1 times 2 for the numerator and 1 times 9. Now what I can do is I'm going to break them apart. And I'm going to apply the quotient property where I can say I could break it apart and make it the square root of 2 over the square root of 9. I now can break down the 9, and I'm left with 3 on the bottom because 9 is a perfect square and the 2 is not. And that's my final answer. Now, this next paragraph that's underneath this example, it's talking about a process that's called rationalizing the denominator. And what we're doing when we rationalize is we're getting rid of a square root that's in the bottom of a fraction. You can never leave a square root in the bottom of a fraction. And in order to get rid of it, we're going to rationalize it. Now, in the example I just did, we did not have a radical left in the denominator because 9 was a perfect square. And once I square rooted it, the 9 came out of the radical and I was left with a 3. You can have a whole number in the bottom of your fraction, but not a radical symbol. So the process of rationalizing the denominator is done right here, and I'm going to do it again over here to the side. So let's say your final answer ended up with the square root of 5 over the square root of 7. Notice the square root of 7 is not a perfect square. And for the rules for radicals, I can never leave a square root symbol in the bottom of a fraction. So what I have to do is apply this technique called rationalizing the denominator. And in order to do that, I'm trying to make my denominator a perfect square. And the easiest way to do that is to multiply it by itself. So what I'm going to do is I'm going to take the radical or the square root that's in the bottom, and I'm going to multiply both the top and the bottom of my fraction by the square root of 7 over the square root of 7. Now, essentially, this right here is equivalent to 1. So technically, all I'm doing is multiplying my given problem by 1, even though it is going to change it. So once I multiply it again, when you multiply square roots, you multiply inside by inside. So 5 times 7 would give me the square root of 35. And then notice when I multiply 7, square root of 7 times square root of 7, I've got a pair of 7s that I'm multiplying, so the 7 comes out. Now, if you want to see it like this, it's really 7 times 7 is 49. 49 is a perfect square. However, you don't need to show me this. Just know that when you multiply a radical by itself, it causes the radical to go away. Now, I still have a radical in the top. I can leave that square root 35. It is not a perfect square because, again, the factors of 35 are 5 times 7. I'm at prime numbers. There's no pairs, so I'm simplified. So whenever you multiply or work with square roots, you can never leave a radical in the bottom, and you're going to need to rationalize. So in this little gray area, it's got the conditions that would produce an expression that's in simplest form. So here, no integral radigan has a perfect square factor other than 1. So again, if it's a perfect square, it's going to come out of the radican, or the radical symbol. No fractions are under a radical sign. So what you would do is break the fraction apart, give it its own radical sign, and then simplify. And again, no radicals can be left in the denominator. Let's try 4 more examples. Move on here and do the next ones. Okay, so again, I've got a division problem. Again, the division problems are written as fractions. Now, at first glance, you're thinking, oh, both of those numbers are prime. But if you remember the rules, you cannot leave a radical in the bottom of a fraction, so I need to rationalize this problem. So again, to rationalize, remember you're going to multiply the top and the bottom by the same square root. So the square root of 5 over the square root of 5, that's what I'm going to multiply the top and the bottom by. And then I get outside times outside, so just put them side by side because there's nothing outside. You can assume a 1 here. And then here, square root of 5 times the square root of 5 is just 5. So that would be your final simplified answer. Now, let's say the denominator was a 6, then I would simplify the 3 and the 6. However, I can't reduce the fraction 3/5, so I leave it alone. The next one, if you remember those rules back in that gray box, it says you cannot leave a fraction under a radical. So what we're going to do is first pull it apart. Now they have their own radical sign. Now I need to rationalize. And there's actually 2 different ways we can do this. I can either simplify the square root of 8 first, because there is a perfect square hiding in there. So I'm going to do that first. I'm going to simplify the square root of 8. And I'm going to do it over here to the side. And this is what we did and what we took a quiz on. We simplified the irrational square roots. So here I can break this into 4 times 2. And again, I could still break it down if you didn't realize 4 was a perfect square. Make your pairs. So I have a pair of 2's. So 1, 2 will come out of this pair, and the 2 that's still left behind stays under the radical. So I can actually simplify this now into the square root of 7 over 2 square root 2. Now again, I can't leave a radical in the bottom. So again, I need to rationalize. So I'm going to multiply the top and the bottom by the square root of 2, because I'm trying to make a pair here and make that radical go away. So now, again, when you multiply radicals, you do inside by inside, outside by outside. So 7 times 2 is 14. And then in the denominator, this pair of 2's makes a 2 come out, and the 2 that's already out there. Everything that comes out now gets multiplied together. So now I have the square root of 14 over 4. The 14 cannot be broken down any further because it's 2 times 7. Both of those numbers are primes, no pairs, so I am finished. I cannot simplify something inside a radical with something outside. So I can't simplify 14 and 4 and make it, divide them both by 2 and make it 7 over 2. That is simplified. Now, the other way would have been to leave the 8 alone, but then you would have had to simplify the top and the bottom. So it's easier if you break down that denominator first. So for example, some students might say, okay, here's my problem. I know I need to get rid of the square root of 8, and instead of simplifying it first, they do something like this. And then you would get square root 56 over 8. But then in the 56, there's a square root that's hiding. So I could actually break this down. I could break it back down to the 8 times 7, or let's see, 14 times 4, 6. So I could break it into 14 times 4. Still have the 8 outside. Then break it down into 2 square root 14 over 8. And then finally simplify the 2 and the 8 and make it square root 14 over 4. So if you do not simplify the square root before you start, then you're going to have to simplify probably the top radical. So it's easier if you try to break down that denominator first and then multiply it by a smaller radical. Let's try C. So this one's got a lot going on here. And I'm going to show you 2 different ways to do this one. So for the 9 square root 3 over the square root 24. Now, I'm going to do it a little differently than what the book did. Let me do it the book way first, and then I'm going to also show you that you could simplify what's under radicals. So what they did was they broke down the 24 first. So let's go ahead and do the factor tree over here. And I can get square root 4 times square root 6, square root 2, 2, 2, and 3. I got a pair of 2's, so a 2 will come out. No pairs, so multiply them back. So I could go ahead and simplify the 24 into 2 square root 6. Now I need to rationalize. So I'm going to multiply the top and the bottom by the square root of 6. And then now I get 9 square root 18. And then the pair of 6's come out as a 6. And then now I can go ahead and multiply and simplify. Now, I could simplify before I multiply. Make this a 2, make this a 3. And then I'm left with 3 square root 18 over 4. Notice now I still have, hiding in my 18, a perfect square. So I have to simplify this. And then 3 times 3. And then now what'll come out, pair of 3's. So 3, a 3 comes out. There was already a 3 there, 2 underneath, and then the 4. So 9 square root 2 over 4. Now, I'll show you a little simpler way. And we were doing this before also. So 9 square root 3 over square root 24. Original problem again. I'm going to simplify what's underneath here. I can divide this by 3 and this by 3. And now I have 9 square root 1 over square root 8. The square root of 1 is 1. So now in the numerator, I just have a 9 over square root 8. And now I already broke down the square root of 8 earlier. Where did I do that? Maybe on the other screen. So square root 8 becomes 4 times 2, and then 2 times 2 times 2, pair of 2's, 2 radical 2. So I'm going to simplify 9 over 2 radical 2, and now I can rationalize. Multiply by radical 2, radical 2. So I get 9 square root 2. Outside stays outside, inside stays inside. And then this pair of 2's becomes 1, 2, I had a 2 outside, so 2 times 2 is 4. Same answer that I got when I did it either way. So it's up to you. Okay, next one, we have a mixed number, some mixed numbers here. Let me go ahead and do it over here. So I have 3 3/7 times 2 1/3. Now, if you remember back from 4th and 5th grade that when you multiply mixed numbers, you need to make them improper first. So I'm going to make both of my fractions improper. So for the first one, 7 times 3 is 21 plus 3 is 24. So I'm going to turn this one into 24 over 7. Then the second one, 3 times 2 is 6 plus 1 is 7. And I get 7 over 3. Now, just like I did before in the first couple examples I did, I'm going to move everything under the same radical. And I'm going to simplify on my diagonals. 1, 1, 1, 8. So now I have 8 times 1, 1 times 1. So I'm just simplifying now the square root of 8. And I already did that. So my answer, which is up here, is going to be 2 square root 2. So this is multiplying and dividing radicals. Let me go ahead and do a couple of them of the oral exercises just so we can make sure we're good. And then I'll give you a few minutes to start looking at the homework. Okay, so your homework officially is 1 through 32 all. But just to show you a couple right here from the simplify. So here, you're multiplying 2 square roots. So both numbers are under the radical. So you would just do 2 times 5. And this answer would be the square root of 10. Now, on this one, you can either decide, I'm going to multiply 3 times 12. And this one's easy, it's small enough. And then the square root of 36 is 6. Now again, if you realize that you'd rather factor them first, you can also do that. 3 times 4. And then the 4 becomes 2 times 2, or pair 2s, pair 3s. So this becomes 3 times 2, which still gives you 6. On number 2, you could either divide this, and 32 divided by 2, because they're both under radicals, gives you the square root of 16, and then it's 4. Or you could rationalize by multiplying the top and the bottom by radical 2. It's a little bit easier if they'll divide. Same thing here. 18 divided by the square root of 3, and you would just get the square root of 6. Once you divide this or simplify this, notice the 6 was in the top, so it's fine. You can leave it alone. On number 8, though, when you try to divide that, you get the square root of 24. 24 still has a perfect square hiding in it, so you need to factor it. 4 times 6, 2 times 2, 2 times 3. Look for your pairs, pair 2s. So a 2 comes out, no pairs here, leave the 6 behind. So if there's still perfect squares hiding in there, you need to simplify. Number 9, notice I can reduce this. I could divide them both by 5. So I would get 1 over the square root of 3. I can't leave that 3 in the bottom, so I have to rationalize. So square root 3, pair 3's in the bottom, so square root 3 over 3. So this is multiplying and dividing radicals, radical expressions. So again, your homework tonight is 1 through 32 all. And then tomorrow we will learn the last lesson of the day, or the whole school year rather, which will be 11-8. So you have a few minutes here. You can start looking at your homework problems. If you have any questions, let me know.